Hello, my friends. Welcome again to SciSpence Labs, where it is all conversions all the time. Today, we are dealing with density and moles. This is 5.4b on page 69. I am sorry for that somewhat racy reference in your moles booklet. All right. So, we are now going to be looking at density and moles because if you recall, density is equal to the mass over the volume. So if you need to find density, density is another division. Okay, that is a division. Just remember, just like molarity was a division. You took the moles divided by the liters, that is a division. But just like molarity could be used as a conversion factor, density can also be used as a conversion factor. And what two things can density convert between? Well, molarity could convert between moles and liters. Density can convert between mass and volume. And molarity, when we dealt with molarity, this was liters of what kind of a substance? Molarity is always for a solution. When we're dealing with density, for the most part, not that you cannot measure density of anything, you could measure the density of a solution, but it's not going to be useful to us here in our mole world that we're in right now. When you are looking at density, this is going to be density of some pure substance. Pure substance. And that means it's going to be some sort of solid. It's going to be a liquid, or it could be a gas. Okay, so this is what's going to be very helpful for us here. And density, of course, can convert between mass and volume. And if you remember, in our little mole doodad here, our moles are here. And off to the right of the moles, there were grams. Guess what? If you have grams, you could find volume of a solid, liquid, or gas, and that would be using density. Now, density can have all kinds of units. It could be the grams per liter. It could be grams per milliliter. It could be grams per centimeter cubed. It could be milligrams per milliliter. You know, I could give you any of those units. So all you have to make sure is that your volume units agree and that your mass units agree. And if you're wanting to find moles eventually, you are going to have it in grams because your conversion factor between moles and grams is the grams per mole, which is the molar mass. Okay? Now, don't get confused. Because I'm going to give you some volumes, don't try and use molarity. Okay? That's going up here. Molarity. And that is liters of a solution. So you have to ask yourself in the question, am I being asked about a solution? It will probably say the word solution. If I'm just being asked about a substance, like say ethanol, and it doesn't say a solution of ethanol, then I'm going to have to know that that is just a volume of a solid, liquid, or gas, and this is a pure substance. Pure substance. Okay? And of course, you know, we could carry this over to our other areas, but right now, on this particular worksheet, 5.4b, we don't need to. We're just going to deal with these three areas. Okay? Okay? And that sounds all very complicated, but it's not. Let's do some examples to see how it's not very complicated. Example. How many moles are contained in 23.0 milliliters of ethanol, which is C2H5OH. Did you notice that prefix F? And how many carbons do we have? We have 2 carbons. And while we're here, I might as well tell you that an alcohol contains the functional group, remember this is the rest of the molecule, OH. Okay? If you have this, that is an alcohol, and it's bonded covalently to the rest of the carbon-based compound. This is totally not what you need to learn right now, but you know I get excited about organic chemistry. So this is called a hydroxyl group. Do you need to know this right now? No. Will it come in handy later? Yes. So here you're introduced to it. Hydroxyl group. Okay, different from hydroxide. Hydroxide is bonded ionically to things. This is a covalent bond. Covalent bond. Okay, so hydroxyl, not hydroxide. Hydroxyl is bonded covalently. Hydroxide is bonded ionically. Anyway, this is an alcohol, ethanol. Okay, and the ending for alcohols is anol. And now, let's get back to business. Ethanol at room temperature is a liquid. And we are going to be told that the density of alcohol, ethanol, is 0.789 grams per milliliter. Now, remember, anytime you have something written with a slash like this, it will do you good to rewrite it as 0.789 grams per milliliter, because then it becomes quite obvious that that is a conversion factor. Okay, so our density is a conversion factor. Okay. Usually one of the easiest things to find is what is your unknown, because it has the question words attached. How many moles? So our unknown is how many moles of ethanol. So that's C2H5OH. And we are told that we have 23 milliliters of ethanol. And so that's going to be our initial quantity. So our initial quantity is, what was it, 23? 23.0 milliliters of ethanol, C2H5OH. And guess what? Our density is given in grams per milliliter. So our units of volume agree already, so we don't have to convert either of them, which is super nice. Density will allow me to convert between milliliters and grams. So I'm going to be able to take my 23.0 milliliters and convert that into grams of ethanol, C2H5OH, and convert it into grams of C2H5OH. And I hope that right now you don't even probably have to look at, this exciting little map up here, because you're like, hey, I can do this volume gram conversion using density, and I know I can do a gram-mole conversion using molar mass. However, if the little map makes you more secure, happier, please feel free to use it. Okay? And if you do like using the map, let's just go back there and take a look at where we'd be starting. We would be starting here with 0.25 milliliters, and we would be converting that into grams of ethanol, C2H5OH, and we would finally, that would be step 1, convert it into step 2, moles of C2H5OH. Okay, so that's going to be the path that we take. But like I said, You don't need to use that if you don't need to. So, how many moles of C2H5OH is equal to, we're starting with 23.0 milliliters times, and we have here, let's see, I need to cancel milliliters and find grams. See, even though my brain has stopped working, I can look at my map and go, I need to cancel milliliters and find grams. I don't even really need to think about it. What is grams per milliliter? Oh, go back to my question. It is 0.789 grams per milliliter. 0.789 grams per milliliter. The power of conversion factors is that they will work even if your brain isn't working. Next, I need to go from grams to moles. So I need to cancel my grams and find my moles. And oh, heck, I need a molar mass for this thing, don't I? So I have, let's see, 2 carbons. I have 6 hydrogens. 5 plus 1 is 6. And I have 1 oxygen. 1 oxygen. And so that is 2 times 12 is 24.0, 6 times 1 is 6.0, and 1 times 16 is 16.0. And I get, let's see, that is 10, 16, carry the 1 is 46. Don't forget, you are adding. When you add up, you have to go to your first uncertain digit, which in this case is in the tenths position. So we must have that 0 there. If you don't write that 0, you will get a half mark taken off from me. Okay? So 46.0, and the unit for molar mass is grams per mole. So we have 46.0 grams per 1 mole. We do that, and we get, oh, it's done for me. That's awesome. 0.395 moles of C2H5OH. Huzzah! All done. My grams cancel out, and I'm left with moles, which is what I wanted.